Nikola Tesla and South Fifth Avenue, Part 2.
In February 1890, the full-page Martin article on Tesla was published in Electrical World, accompanied by a very prominent photograph of the youthful-looking engineer.
For Tesla, it was excellent publicity, the first major essay to appear portraying the up-and-coming inventor. A meeting of the AIE, devoted entirely to the new Tesla AC system, was planned for the following month.
In particular, the conference had been sparked by a number of important developments, most notably plans coming from Switzerland and Germany for apropos long-distance AC power transmission experiment, the impending success of the Westinghouse company in instituting a hydroelectric plant utilizing the Tesla AC system at a mining camp in Telluride, Colorado, and the announcement of an international Niagara Commission to look into the best way to harness Niagara Falls. At the March AIE meeting, Prof. Louis Duncan was the main speaker. His lecture began with a mathematical dissection of the workings of the novel and admirable little machine invented by Mr. Tesla, a former officer from the U.S. Naval Academy. Duncan had recently transferred from the South Pacific to Johns Hopkins University, where he stayed on to teach. An important ally, he gave the Tesla invention academic credibility. The great advantage of the motor, Duncan said, lies in the fact that it has no commutator and it permits the use of very high voltages. In the future, power will be transmitted electrically at voltages that will make machines with the commutator next to useless. After the lecture, there was a discussion, and Tesla participated.
Pupin, who spoke that summer in Boston and again in New York the following year on alternating current theory, was fast becoming an admirer of Tesla's work. However, at the same time, Pupin was also becoming embroiled in the controversy as to who was the real author of the AC polyphase system, and from Tesla's vantage point, Pupin made the mistake of befriending the wrong people.
At the Boston meeting, Pupin noticed that my audience was divided into two distinct groups. One group was cordial and appreciative, but the other was as cold as ice. The famous electrical engineer and inventor, Elihu Thomson, was in the friendly group, and he looked me up after the address and congratulated me cordially.
That was a great encouragement, and I felt happy.
Other prominent individuals, however, tried to have Pupin fired from the electrical engineering department at Columbia because of his adherence to AC, but Pupin overrode the controversy and at the same time increased his friendship with Thomson. Unbeknown to Pupin, Thomson himself was in a quandary because he now recognized the clear advantage of the Tesla system, but he was locked out of its use because Westinghouse owned the patents. Although the Thomson-Houston Electric Company was extremely profitable, the concern faced certain doom if it was unable to use efficient AC machinery.
As Elihu Thomson had worked with AC for over a decade, he felt fully justified in adapting a Tesla-like system, especially because there were other engineers who also claimed legitimate priorities of a respective system, notably Schellenberger and Ferraris. Furthermore, Thomson himself had come close to conceiving as a minor workable plan. That Tesla held fundamental patents on a completely revolutionary invention was continually overlooked by Thomson as he sought ways to rationalize his position while working at his company, presiding at the AIE, and writing in the electrical journals. He had successfully circumvented the Edison-libel patents by paying Sawyer 4 cents to produce the stopper lamp, an exhausted light bulb similar to Edison's, which used a rubber plug stopper to hold in the vacuum, and so he sought a similar tack with AC. During a heated series of articles in Electrical World between Thomson and Tesla, it appears that Thomson admits to some of his distaste for his rival when he writes, "I confess that my statement as to the motive of my critical remarks may have been out of place."
They were elicited, however, by Mr. Tesla having on a former occasion misunderstood my motives, and so Pupin's feelings for his Serbian brother became undermined as his friendship with Thomson grew. Tesla agreed to present his work in high-frequency phenomena during a 3-day symposium of the AIE, which was held in May 1891, 3 months after he first published his research on the topic. Hall was booked at Columbia College, which, at the time, was located between Park and Madison Avenues on 49th and 50th Streets, and the public was invited.
It is difficult to calculate the enormous impact that this lecture had on the engineers of the day and on the course of Tesla's life, for it is clear that after the event Tesla was perceived in an extraordinary way.
Joseph Wessler, or Josh, as he preferred to be called, covered the talk for Electrical World.
But Tesla's lecture was too important for a single exposure in a journal of limited circulation, and Tesla was able to also peddle the piece as a spectacular full-page account in the prestigious Harper's Weekly.
With lucid explanations in pure nervous English, Tesla proclaimed, this stripling from the dim borderland of Austro-Hungary had not only gone far beyond the two distinguished European scientists Dr. Lodge and Professor Hertz in grasp of electromagnetic theory of light, but he had actually made apparatus by which electrostatic waves or thrusts would give light for ordinary everyday uses. Tesla had not only presented a remarkable display of electrical phantasmagoria, he had also outlined new, fundamental and far-reaching principles.
Tesla cogently pointed out that Tesla had gone far beyond Heinrich Geissler and Sir William Crookes in the production of light by use of vacuum tubes, and he had also eclipsed the wizard of Menlo Park with his refinements of the incandescent lamp.
But Mr. Tesla was not satisfied with these results, brilliant as they were. He had set himself no less a task than to create a lamp which, without any external connection to wires, would glow brightly when placed anywhere in an apartment.
And if that were not enough, for a conclusion, Tesla passed tens of thousands of volts of AC through his body to light up light bulbs and shoot sparks off his fingertips, and to show the world that it was not at all a killer current when utilized correctly.
Exhausted tubes, held in the hand of Mr. Tesla, appeared like a luminous sword in the hand of an archangel representing justice, said one reporter. With Garno Dunn, his assistant, Tesla began his talk somewhat nervously but gained momentum as he progressed. Of all the forms of nature's immeasurable, all-pervading energy, which ever and ever change and move, like us all animates an innate universe, electricity and magnetism are perhaps the most fascinating.
We know, Tesla continued, that electricity acts like an incompressible fluid, that there must be a constant quantity of it in nature, that it can neither be produced or destroyed, and that electric and ether phenomena are identical. Having set up the premise that our world is immersed in a great sea of electricity, the wizard proceeded to astound the audience with his myriad experiments.
And at the end, Tesla's matched his opening in poetic expression. We are whirling through endless space, with an inconceivable speed, he said. All around us everything is spinning, everything is moving, everywhere is energy. Based on this premise, Tesla ended with a prophetic supposition, which has often been interpreted by some to suggest that as a point or free energy strata exists, there must be some way of availing ourselves of this energy directly, he said.
Then, with the light obtained through the medium, with the power derived from it, with every form of energy obtained without effort, from stores forever inexhaustible, humanity will advance with giant strides. The mere contemplation of these magnificent possibilities expands our minds, strengthens our hopes, and fills our hearts with supreme delight.
Those who attended the lecture, including Professor Anthony, Alfred Brown, Elmer Sperry, William Stanley, Elihu Thompson, and Francis Upton, would remember the historic occasion for the rest of their lives. Robert Millikan, for instance, who later won a Nobel Prize for his work with cosmic rays, was a graduate student at Columbia at the time.
He said many years later, I have done no small fraction of my research work with the aid of the principles I learned at night.
Michael Pupin, who also attended, however, appears not to have been so entranced. While IWA's lecturing, Tesla told a Serbian reporter, Mr. Pupin, with his friends, most likely, Elihu Thompson and Carl Herring interrupted ... by whistling, and I had difficulty quieting down the misled audience.
Pupin wrote to Tesla to smooth things over and to set up an appointment to see the motor, as he was scheduled to deliver a number of lectures on polyphase currents. But Tesla avoided him in Europe. Rumors began to circulate about the new electrical Svengali in America, and Tesla was quickly invited to speak before European scientific societies.
End of Part 2, Nikola Tesla and South 5th Avenue. Thank you for watching. Please like, share and subscribe.